Morning gamers. Today we have a crap ton of flashcards to go through. 9:27 right now. By the time this recording, I've only gone through 62 cards today. When I've been getting through 600 in the past 3 days or so. So decided to procrastinate today, which is a terrible idea. Don't do that. So you're gonna go through with me and let's get through these flashcards. I kind of want some music while I listen to this. I'm probably going to use headphones. Yeah, these are good. I need headphones to get me through this. So plug this in. Hopefully it works. Alright. And just play my favorite track. Like a trance remix study. This one's good. Get some water too. And start on the chapter 8. Alright, here we go. 1 hour session. Looks like it's recording. Let's begin. 37 cards to go through. What is one type of way that pathogens have evolved defense against immune system? How did the immune systems respond? They're able to downregulate immunity, making it harder for T cells to recognize the presence of an infection. In response, the immune system has natural killer cells that are able to detect MHC downregulation and improves apoptosis. One type of way that pathogens have evolved defense against the immune system. Pathogens downregulate MHC molecules, making it harder for the T cells to recognize a presence of infection. So the immune system has natural killer cells that detect that downregulation, induce apoptosis of these infected cells. Which type of immune systems surround the digestive system, a site for potential invasion by pathogens? The gut-associated lymphoid tissue, gout, which induces tonsils and adenoids in the head, Peyer's patches in the small intestine, and lymphoid aggregates in the appendix. It's a lot. The gut-associated. Tonsils, adenoids in the head, Peyer's patches, small intestine, and lymphoid aggregates in the appendix. That's one point I'm not going to remember. What is clonal selection? Basophils that can bind to the antigen with high affinity survive, providing a mechanism for generating specificity. Only B cells that can bind to the antigen with high affinity survive, providing a mechanism for generating specificity. Describe the steps of what happened in bacterial extracellular pathogen infection. So if we have a bacteria inside the cell, or inside the body, then we have MHC class 2 molecules that act, or phagocytes will engulf the bacteria through phagocytosis, or endocytosis, rather. And use MHC class 2 to present fragments or peptides of the bacteria to act as antigen presenting cells for T cells to detect that, and T cells will kill that cell, that endosome containing the bacteria. This one's longer. Macrophages engulf the bacteria and release inflammatory mediators. They present antigens to the pathogen on their surface in conjunction with MHC class 2, and always releasing cytokines to increase more inflammatory cells. Mast cells are activating inflammation, degranulate, producing histamine. Dendritic will go into lymph node and present antigen to B cells. Okay, this is way too long. This is a really bad card, to be honest. Lymphatic system is involved in equalization of fluid distribution, transportation of fat and fat-soluble compounds and chylomicrons, providing site of mounting immune response. Equalization of fluid distribution, transportation of fat chylomicrons, and site of mounting immune response. So fluid distribution, fat transportation, and fat soluble compounds through chylomicrons, and site for mounting immune response. What is the main agranulocyte in our body? What does it do? Lymphocytes are the main agranulocytes in our body, and they're involved in lymphocytes, right? Lymphocytes involved in killing infected cells. Is it specific response? Man, this is so hard. Antibody production, immune system modulation, and killing infected cells. How can I remember this? Late, L-A-I-T. Late. Antibody production, immune system targeting and killing cells. Professional antigen presenting cells. So we have macrophages, we have dendritic cells, we have some epithelial cells. Some B cells. Granules contain toxic enzymes that can be secreted through exocytosis to kill cells. Released by effective against pathogens. What is isotype switching? Isotype switching is isotype switching. It's not isoform switching. Isotype switching. Oh, it was this one. What the hell? Has 5 different isotypes and these different time reactive. So change produced in certain cytokines. Cells can change which isotype of antibody you produce when stimulated by specific cytokines. Each beta cell makes one type of antibody, but we have many beta cells that can produce a wide variety of antibodies. T cells are involved in cell-mediated immunity, and they're responsible for killing cells. Virally infected cells. 2 types of leukocytes are the agranulocyte and granulocytes, depending on the granules found inside the cytoplasm. Describe the substance intracellular pathogenic infection, like a virus. So, virus dumps its material into a cell. Cell will produce interferons, and those interferons will also recruit other cells into the area. They use MHC class 1 to present antigens on the surface of the cell to be recognized by macrophages, which then engulf the cell. Okay. So it's the cytotoxic T cell that does the killing, not the macrophages. And if the MHC is downregulated, then we have natural killer T cells that recognize this downregulation and also induce apoptosis. And once the viral infection is cleared, then we have memory T cells that generate and remain. What do neutrophils do? How do they move through the environment? So they move through chemotaxis or fellow bacteria that have been opsonized or marked by antibodies, and neutrophils will... Man, I keep forgetting these neutrophils and eosinphils and basophils. They're so complicated. Neutrophils will kill... do they kill cells? Non-specific. They're all involved in non-specific defense. And they're phagocytic. Non-specific defense and phagocytic. Fellow bacteria is using chemotaxis. Non-specific defense and phagocytotic. Eosinphils. I just said this. Eosinphils are involved in what? It's a granulocyte involved in non-specific defense too. This is the one involved in allergic and parasitic infections, where it causes release of histamine, which increases leakiness of the blood, and vasodilation, which causes immune cells to move out quicker into the tissue. Okay. Self-antigens are antigens that body cells produce to allow them to be recognized as not being foreign by immune cells. What is positive selection T cells? So these are T cells that respond to foreign antigen. Innate and T cells that respond to self-antigen are destroyed. And that's through negative selection on MHC. Allowing for maturation cells that respond to the presentation of antigen on MHC. Major histocompatibility complex. Negative selection is causing apoptosis in cells that are self-refractive. T cells mature in the thymus, in the pericardium, which is near, or in thymus, which is a structure near the pericardium, which is a sac that surrounds the heart. Okay. What are monocytes? Monocytes are phagocytic cells in the bloodstream, but when activated, they become macrophages in tissue. They're also agranulocytes. I keep forgetting that. I think I already know that. Phagocytic cells become macrophages in tissue. Hormone thymosin is used. It's a peptide hormone secreted by thymin in the thymus, which allows for maturation of the T cells. But for thymic cells in the thymus. So thymosin is a hormone secreted by thymic cells in the thymus, and this hormone causes maturation of T cells. MHC class 1 molecules are found in all nucleated cells of the body. Passive immunity is transfer of antibodies to the individual. Transfer of antibodies into the individual. Primary response, secondary response, which is faster. Primary response is initial activation of B cells with foreign antigens. It's faster than memory. B cells can produce antibodies specific to that pathogen immediately. And primary response is the initial activation of B cells to a foreign antigen. Secondary response is when we have memory B cells that produce antibodies specific to that pathogen immediately. Beta cells mature in the bone marrow. They're mature when they leave the bone marrow, but naive because they haven't been exposed to antigens yet. What is another name for innate immunity? Non-specific immune response is another name for innate immunity. Non-specific immune response. Non-specific immune response. What is the name for innate immunity? Non-specific immune response. How does the body prevent autoimmune reactions? T cells are educated in the thymus. T cells that respond to self-antigens are eliminated through negative selection. B cells where T cells and B cells that respond to self-antigens are eliminated through negative selection. Okay. So in the thymus, they're educated, and T cells are self-reactive, respond to self-antigen, and B cells too are eliminated. What is the one type of way that pathogens have evolved a defense against immune systems? They now downregulate MHC molecules, so they don't present the antigens on the cell. And the immune system has a natural killer T cell that recognizes downregulation to induce apoptosis of these cells that have a decrease in MHC from the pathogen. What type of immune tissue? So it's gut-associated lymphoid tissue, or gout, contains Bayer's patches in the small intestines, lymphoid aggregates in the appendix, and or in the stomach. Oh, I forgot the specific. Tonsils, adenoids in the head, Bayer's patches in small intestines, and lymphoid aggregates in the appendix. Tonsils and adenoids in the head, Bayer's patches in small intestines, and lymphoid aggregates in the appendix. What is clonal selection? Clonal selection. Oh, only beta cells are combined to antigens with high affinity primary mechanism for generating specificity. That's clonal selection. What are the forceps of macros units to invading bacteria? First, we have the bacteria. They get engulfed by a bacteria. Let's see. MAC class 2 brings in and presents it on cells, and then is it macrophage to come in and engulfs it? Okay. So macrophages first phagocytize the invader through endocytosis using enzymes, then presents little fragments to other cells using a protein. Oh, so MHC class 1 is in the macrophage, which tends to release cytokines. This is a inflammation condition. Okay. We first have the macrophage, which contains MHC class 1 molecules. And the bacteria comes in. The macrophage will eat the bacteria through endocytosis. And once a macrophage has eaten the bacteria, it uses MHC class 1 molecules to bring small peptides or antigens of the bacteria onto its surface, while also releasing cytokines, which are chemical substances that stimulate inflammation and recruits additional immune cells to the area. Cool. Just what happens in a bacterial. I mean, we just went over this, right? I'm going to say it again. Oh, they use class 2. Okay. Yeah, this one's just way too long. What is the lymphatic system is involved in equalization of fluid, site to mount an immune response, and the lymphatic systems also in transportation of fat and fat soluble compounds through chylomicrons. Macrophages, phagocytotic cells that become activated when it goes into a tissue from monocytes. Becomes activated when a bacterial invader enters a specific tissue, and they're granulocytes. What are memory T cells? No idea. Similar to memory B cells, but they wait till the next exposure to the same antigen when activated and carry a faster response. Similar to memory B cells, they wait until the next exposure to the same antigen and carry out a faster response. What is adaptive immune system? Defenses that target a specific pathogen, slower to act but maintain a memory of an infection about and subsequent infections. So specific targeting of a pathogen, slower to act, but it maintains a memory so that when there's a subsequent infection, it's a lot faster to attack. Cytotoxic C cells are CD8 positive cells, capable of killing virally infected cells by injecting toxic chemicals that induce apoptosis. They respond to antigens presented on MHC class 1 molecules. Killing virally infected cells by injecting toxic chemicals that promote apoptosis. They respond to antigens presented on MHC class 1 molecules. Isotype switching is the fact that we have 5 different isoforms of antibodies, and an adaptive immune system we're able to switch which isoform of antibody we're using based on the cytokine released. The main granulocyte in our bodies are lymphocytes and is involved in I keep forgetting this. Lymphocytes involved in killing virally infected cells and antibody production and mounting an immune response. LAIT. I'm going to put that there for some reason. LAIT. What is the main ingredient in our body? Lymphocytes involved in antibody production, immune response, modulating immune response, and killing cells. Targeting. Okay. What are some professional antigen macrophages, dendritic cells, some B cells, and some epithelial cells? Granules contain a toxic enzyme that can be secreted by exocytosis, and those things will kill cells. Pathogens. MHC class 2 called the exogenous pathway. So you have MHC class 2 here. We bring an enzyme in there. These molecules display antigen presence in macrophages. They're displayed by antigen. We're going to pick up pathogen and place them MHC class 2. These from the cell. Okay. Molecules displayed by antigen presenting cells such as macrophages, and these macrophages will pick up pathogens from the environment and place them on MHC2. The antigens originate outside from the cell. Describe the symptoms involved in a intracellular pathogenic infection like a virus. Virally infected cells produce interferons. Infected cells present intracellular viral proteins to the surface in conjunction with MHC class 1. Does not disease recognize the MHC 1 and antigen complex as foreign and will induce apoptosis and these MHC class 1. That's clear. Okay. Gotta do it again. What do T cells do? T cells are killer cells, so they'll kill virally infected cells, agents of cell-mediated immunity, and coordinate the immune system. Involved in cell-mediated immunity. Coordinate the immune system. Keep forgetting that. Keep mixing some of them up. Where do granules come from? Hematopoietic stem cells, question mark. What do neutrophils do? Neutrophils are involved in killing virally infected cells, and they move to the environment through chemotaxis or following opsonized pathogens, which have been tagged by antibodies. Agents of non-specific immunity and are phagocytotic in the bloodstream. Cool. Positive selection of T cells, selecting T cells that recognize foreign antigens, and negative selection is killing T cells that are self-reactive or recognize self-antigens. What are 3 protocols that antibodies will follow up secrete into body fluids? Opsonation, which is one bodies may track other leukocytes if phagocytose those antigens. Immediately agglutination. Pathogens clump together to form an insoluble complex that becomes a neutralization, block the ability of pathogen to invade tissues. Okay. Opsonation, agglutination, and neutralization. Opsonation is when bounded to the antigen, it attracts other leukocytes to kill or phagocytose those antigens immediately. Agglutination is the formation of a large insoluble complex of pathogens that will be phagocytosized. And neutralization is antibodies perfects the ability of pathogen to invade tissue. Eosinphils are involved in parasitic infections and allergic reactions. They cause the release of histamine, which causes leakiness of blood vessels, and vasodilation, which allows for the secretion of more immune cells into the area. And they're involved in non-specific defense. So all granulocytes are involved in non-specific defense. Both allergic invasive, release histamine and pollen causes leaking blood cells immune system to move blood into tissue. Passive immunity is injecting an antibody into a person. Primary response is the B cells producing antibodies to a new foreign invader. Secondary response is using memory B cells to produce an antibody specific to the antigen. Second response are always faster. Beta cells mature in tissues when bacteria or pathogens enter. No, they are mature. Oh, not where to activate. Mature when they leave the bone marrow, but naive because they haven't been exposed to antigens yet. Whereas the hormone thymosin is a peptide hormone secreted by thymic cells in the thymus. Thymic cells in the thymus, which causes activation of T cells. Yeah. Innate immunity, adaptive, non-specific immunity. That was kind of hard, but whatever. How does the body prevent autoimmune reactions? The T cells become educated in the thymus, quote unquote, in that T cells that recognize self-antigens and B cells that recognize self-antigens are destroyed by apoptosis in negative selection. What are helper T cells? They coordinate immune response by secreting lymphokine chemicals, not cytokine, lymphokine chemicals, which recruit our immune cells. It's kind of the same thing. Respond to antigens prevented on MHC2 molecules. Coordination of the immune response by secreting lymphokine chemicals, which recruit other immune cells and increase their activity. They respond to antigens presented on MHC2 molecules specifically. Okay. Coordinate immune system by secreting lymphokine, which recruits other immune cells and increase activity, respond to antigens present on MHC class 2 molecules. Where does the lymphatic system connect to the cardiovascular system? Thoracic duct in the posterior chest. 3 types of T cells: cytotoxic T cells, natural killer T cells, and helper T cells. Suppressor T cells? Okay. What is active immunity? Immune system is stimulated to produce antibodies against a specific pathogen. Macrophages do. So macrophage will engulf the bacteria first, and it presents fragments of the bacteria called antigens through MHC molecules, where a T cell can come in and kill the macrophage carrying the bacteria. And if there happens to be a downregulation of MHC, then we can have natural killer T cells that come in and kill the bacteria. Oh, keep forgetting cytokines. Clonal selection is the process of clonal selection. I remember this. Clonal selection is the process of only allowing beta cells that bind to the antigen at high affinity survive, while beta cells that bind to antigens at low affinity die out. Describe what does that happen when a bacterial extracellular pathogenic infection occurs. So yeah, we have the macrophage that comes in and engulfs the bacteria through endocytosis and breaks it down using its own enzyme. Then we have MHC class 1 molecules that present pieces of the bacteria on the surface of the macrophage. Then we have the natural killer T cells. We have killer T cells that come in and recognize the antigen and bind to it. In the case where the bacteria decreases MHC class 1 molecules, then we have natural killer T cells that come in. And we also release cytokines too, but keep forgetting that. Okay. What type of immune system? We have the gut-associated lymphoid tissue, which is associated with the tonsil and adenoids in the head, Peyer's patches in small intestines, and lymphoaggregates in the small appendix or in the appendix. Macrophages are phagocytotic cells. They're derived from monocytes, and they become activated when a pathogen enters its tissue. Memory T cells. Similar to memory B cells in that they await until next exposure of the same antigen and will activate and carry out a faster response. The adaptive immune system. Defenses that target a specific part so to act to maintain immunological memory of an infection to mount a faster attack and subsequent infection. Defenses that target a specific pathogen, slower to act but can maintain immunological memory of an infection to mount a faster attack in subsequent infections. Slower to act but maintain a memory of the infection to mount a faster attack in subsequent infections. Okay. Cytotoxic T cells. What do they respond to? Oh, let me see. Killing virulent infections by injecting toxic chemicals that promote apoptosis and respond to antigens presented on MHC1 molecules. The innate immune system is a name for non-specific immune system. The innate immune system is composed of defenses that are always active against infections. What type of antibacterial lysozyme? What? Defensin? Okay. What do toxic chemicals that can be secreted by exocytosis, and those toxic chemicals will kill cells, promote apoptosis. Granules? Why do granules kill pathogens? It's called the exogenous because we take the macrophage takes in an antigen from the extracellular matrix and then brings it in and hooks it up to an MHC class 2 molecule to present it on its exterior. Humoral immunity is antibodies acting in the blood rather than tissue. Production of antibodies from B cells and specific to the antigen of the invading microbe. Humoral immunity is anti-production of antibodies from B cells, and these are specific to the antigens of the invading microbe. Granules come from hematopoietic stem cells for some reason. Describe a step in the intracellular pathogenic infection. This one's a long one. Interferons, protein that cell produces when they become infected with viruses, preventing bioreplication and dispersion, and upregulates MHC class 1 and class 2. Okay, makes sense. Protein that cell produces when they have become infected with the virus, preventing viral replication and dispersion, and replication of MHC class 1 and class 2. Or the ways in which the gastrointestinal tract can play a role. So it contains enzymes that are, it's a sick environment that kills some pathogens, and we also have, so stomach has acid which kills pathogens, and bacteria that compete with other invaders to keep them out of the way. What do T cells do? T cells are agents of cell-mediated immunity. Agents of cell-mediated immunity they kill virally infected cells, basically. So antibodies can do opsonation, which is marking of a bacteria using antibodies to recruit more immune cells to it. Then we have opsonation. I forgot it. Agglutination and neutralization. Antibodies may cause pathogens to clump together, forming a large insoluble complex that will be phagocytosized. Neutralization. Antibodies can block the ability of pathogens to invade tissue. Neutralization. Antibodies can block the ability of pathogens to invade tissue. Opsonation, agglutination, neutralization. Naive B cells hang out in the lymph node until their antigen comes along. Producing plasma cells, memory B cells. Humoral, innate immunity and adaptive. Basophils and mast cells. They're granulocytes involved in non-specific defenses, of course. Involved in allergic reactions, rare in the bloodstream, and they release a huge amount of histamine in response to allergens. Involved in allergic response and rare in the bloodstream, releasing huge amounts of histamine in response to allergens. Non-specific defense. Okay. What does MHC do? Prevents antigens on the surface of cells. The adaptive immune system. What is the lymphatic? Lymphatic system is circulatory system consisting of one-way vessels with lymph nodes. Circulatory system that consists of one-way vessels with lymph nodes. What is called the endogenous pathway. Any protein produced within the cell will be loaded onto MHC presented. Okay, any protein produced within the cell will be loaded to MHC1 and presented to the surface of the cell. What are suppressor regulatory T cells? What do they respond to? They differentiate from helper T cells, and these cells tone down the immune response once infection has been contained, and they also turn off self-reactive lymphocytes to prevent autoimmune disease in a process called self-tolerance. What are differentiate from helper T cells, and they tone down the immune response once infection has been contained, turning off self-reactive lymphocytes to prevent autoimmune disease. Okay. They differentiate from helper T cells. They tone down the immune response when it's complete, and they turn off self-reactive lymphocytes to prevent autoimmune disease in a process called self-tolerance. What are helper T cells? Helper T cells secrete lymphokine chemicals that recruit other immune cells and increase their activity and respond to antigens presented on MHC2 molecules. They coordinate the immune response by secreting lymphokine chemicals. Helper T cells coordinate the immune response by secreting lymphokine chemicals which recruit other immune cells and increase their activity. Helper T cells. How do they help? They secrete lymphokine chemicals. So they help in that they secrete lymphokines that recruit other immune cells to increase their activity and respond to antigens presented on MHC2. So recruiting and presenting and recognizing antigens presented on MHC2. Lymphatic system connect to the cardiovascular system through the thoracic duct located in the posterior chest. Three types of T cells: cytotoxic T cells, helper T cells, suppressor T cells. Active immunity is the formation of antibodies specific to an antigen. Production of antibodies specific to an antigen. Yeah. B cells mature in the thymus, B cells mature when they leave the bone marrow, but they're considered naive because they haven't been attached to an antigen yet. What are the four steps? Invade macrophage, engulf bacteria, digest it, use MHC class 2 or class 1 to present the antigen on the front, and also release cytokines to recruit other immune cells. Plasma cells and memory B cells derived from B cells. Daughters of B cells. Antibodies and B cells. Exposure. Daughters of B cells. Plasma cells produce antibodies, while memory B cells stay in the lymph nodes waiting for re-exposure to the same antigen. Which cell governs the humoral response? Cell-mediated response. B cells govern humoral response. T cells mount cell-mediated response. B cells is humoral. Think B as humor. Bitches are humor. And T's are cell-mediated. Bitches are humor. Bitches are humorous. Bitches are hilarious. Bitches have humor. Okay, that's one way to recognize it. Cell surface follows opsonation, which is targeting of bacteria pathogens using the antibodies, secreting cytokines. Agglutination, something like that, which is where you form an insoluble complex of pathogens to be later digested. And then there's also neutralization, where we prevent pathogens from spreading. Oh, this is different. Oh, man. Cell surface antibodies. Oh, man, this is so long. Binding of an antigen to B cell causes activation of that cell, resulting in its proliferation and formation of plasma. Binding of an antigen to a B cell causes activation, which causes proliferation of it, and it produces memory B cells and plasma cells. Cool. But then this part, binding of an antigen to antibody. So this is the next step. Antigens to an antibody on a surface of mast cells causes degranulation, which is exocytosis of granule contents, which releases histamines and causing an inflammatory response. So I have about 25 left. I think I'm going to stop here for now, and then I'll get back because I don't want the video to be too long.